Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on boost converter. Here boost converter means so here lower input voltage and higher output voltage. Boost converter is a type of DC to DC converter that set up say lower voltage to higher voltage, means here Vs is the supply voltage and output voltage is a V0. So now here V0 is greater than Vs. In case of buck converter, so now here V0 is less than Vs. So this is the difference between boost converter and buck converter. Here this is the case, output voltage is greater than supply voltage. We are boosting the voltage, so increasing the voltage. So here the components used for this boost converter are one inductor and next one switch and next one freewheeling diode, and here is a capacitor. Now here in this, so when switch is on, when switch is closed, calculate the inductor voltage and calculate the capacitor current. And same way when inductor is open, means off, so that is open circuit, means here and in that case VL off and IC off. And next here volt second balance, here VL on plus T on plus VL off plus into T off is equals to 0. This is volt second balance. Ampere second balance means IC on T on plus IC off T off is equals to 0. Here T on means equals to D into T and T off equals to 1 minus D into T. So T on plus T off is equals to T only, total time period, and D equals to T on by total time period T, means that is T on plus T off. And next ripple in the inductor, so that is DL by D delta IL, and next IL maximum, IL minimum, source current IS and switch current ISW and diode current ID, and ripple in the capacitor voltage VDC, and duty cycle at this duty cycle. So ripple in the voltage is maximum, that duty cycle value, and capacitor, critical capacitance, inductance and critical capacitance value. So these are we need to derive. First, when switch is on, calculate this voltage across the inductor and current flowing through this capacitor. When switch is on, means this switch should be short circuit. So switch should be closed, means that is short circuit, and it is here switch is closed, so this is short circuit. This is short circuit, and during this condition, in this condition, apply KVL in this loop. So Vs is equals to VL. So VL on equals to Vs only. This is the case. So when switch is on, calculate the voltage across the inductor. That voltage across the inductor equals to Vs only. Same way when switch is on, so this is completely one circuit and this is another circuit. So there is no DIL. So this is up to here, this is short circuit. There is no current flowing through this. So IL value is 0 equals to IC plus I0. So now IC equals to minus I0. If you apply KCL, so there is no IL. So IL value is 0. And next here IC plus I0 equals to 0. If you apply KVL here and apply KCL here. Now here this is turn on. Now IC on equals to minus I0. Now when switch is off, calculate the VL. So when switch is off, means this is open circuit. This is open circuit and calculate the VL off. So now VL equals to Vs minus V0, means if you apply KVL in this is open circuit, KVL in this, so now Vs equals to VL plus V0. So now VL equals to Vs minus V0 and VL off, this is off condition switch, so now Vs minus V0. So now when switch is on, when switch is off, calculate the voltage across the inductor, so that value equals to, that is Vs minus V0, and when switch is off. So there is an inductor current, same current. This is open circuit. There is no path here, and this IL, if you apply KCL at this node, and next IL equals to I naught plus IC, and next IC equals to IL minus I naught, and next here IC equals to IL minus I naught. Now here IC of this one, this is IC of condition, that equals to IL minus I naught. So this is the case. So now we calculate the when switch is on, voltage across the capacitor, inductor and capacitor current, and next when switch is off, so calculate the voltage across the capacitor, inductor and current flowing through the capacitor. So these are the formulas. And volt second balance. Volt second balance means VL on into T on plus VL off into T off. So what is this is T on means D into T, and next this is 1 minus D into T. So this is total time period T. So now here T equals to T on plus T off. So now here this VL on already we derived. This VL on means this is Vs, and this T on means that is D into T, and plus VL off means already we derived. So Vs minus V naught, and T off means 1 minus D into T is equals to 0. This is the old second balance equation. So if you substitute VL on and VL off and T on and T off. So now if you simplify this one, so now Vs into dt plus Vs into 1 minus D into T, 1 minus D into T minus of V naught 1 minus D into T is equals to 0. So now Vs into dt plus Vs T minus Vs into dt. So minus V naught 1 minus D into T is equal to 0. So now this is negative and this one is positive. So now gets cancelled. Now Vst is equals to V naught 1 minus D T. Tt gets cancelled, LHS and RHS. Now V naught equals to Vs by 1 minus D. So this is the output voltage. So now V naught equals to supply voltage divided by 1 minus D. So now D value is always 0 to 1. So now this value 0 to 1 means always V naught is greater than Vs. So supply voltage is always less than the output voltage. So that is boost converter. So this is the output voltage formula. This is equals to the supply voltage Vs by 1 minus into duty cycle. So duty cycle equals to D equals to 1 minus T, and that equals to T on by T on plus T off. So now here ampere second balance, in the ampere second balance IC on into T on plus IC off into T off. So that equals to into T off equals to, that equals to 0. So now here IC on equals, that equals to minus I naught. So when switch is on, so for that case that equals to minus I naught. So that equals to D into T. T on means that equals to plus, and next here IL minus I naught into 1 minus D into T. So here you need to calculate inductor current. So now here minus I naught into dt plus IL into 1 minus D into T minus I naught into 1 minus D into T equals to 0. So now here minus I naught dt plus IL. We need to calculate this IL equals to. So now here IL 1 minus D into T. So minus I naught plus I naught into dt is equals to 0. So now this is minus and this one is the plus, and it gets cancelled. So now here IL into 1 minus dt. This is T. So now equals to I naught into T. Tt gets cancelled, and next here IL equals to I naught by 1 minus D. So this is the inductor current. So here from the old second balance, so IC on into T on plus IC off T off is equals to 0. That is the old ampere second balance. So if you substitute IC on and IC off and T on and T off formulas, and you will get the inductor current IL equals to I naught divided by I 1 minus D. In case of buck converter, IL equals to I naught only. So now here next formula. Now here ripple in inductor. Ripple in inductor means when switch is on. So now here L DIL by dt is equals to V naught, and now V naught equals to D into Vs. Sorry, this is Vs. So now here, so V naught means here inductor voltage when VL on. So that equals to Vs only when inductor is on. So this when switch is on, so during that case, so that inductor voltage is Vs only, and this is L into del IL divided by dt. T on means here that is Vs. So now here del IL equals to Vs into D by into T by L, that equals to D into Vs by F into L, that is del IL. Ripple in the this is the inductor current IL equals to, now here this is this one is the del IL. Now here this is del IL by 2, and this one is the del IL by 2, and next here this is IL minimum and this is IL maximum. So IL maximum and IL minimum. So now here this one is a formula D into Vs by F into L. So ripple in the inductor current. And next, what about this one? IL maximum equals to IL plus del IL by 2. Just substitute in this, you will get the IL maximum value. And next here IL minimum value equals to IL value we calculated minus del IL divided by dt. Sorry, 2. So now here IL value equals I naught by 1 minus D, already we calculated, and del IL means D into Vs by F into L. Substitute in this, you will get IL maximum and IL minimum. Just plus or minus. Plus means here plus for maximum and minus for minimum. And next here source current. So here P input equals to P output. So input current and input voltage equals to P source current equals to Is into Vs. This is Is into Vs equals to V naught into I naught. So now here Is equals to V naught by I naught by Vs. So now here V naught equals to Vs by 1 minus D by Vs and I naught. So this I naught means here V naught by R. Again substitute this Vs by 1 minus D. Substitute in this, you will get. So just remember this formula, Is equals to V naught and I naught by Vs. So here this is the source current. And what about switch current? Switch current equals to, here switch current means ISW. ISW equals to IL into. Now here what about this one? IL into this value equals to this. Here same IL output voltage, this IL average when switch is on. So this inductor current when switch is on. So inductor current only when switch is on condition. Switch is on condition means dt into T. So that equals to IL into D. So IL means I naught into D by 1 minus D. And when switch, this is average value only. So for ISW RMS value equals to IL into, so square root dt by T, that equals to IL into square root D, that equals to I naught into square root D by 1 minus D. IL means I naught by 1 D. This is switch current. Now here what about diode current? So diode current means when switch is off. So when switch is off means current flows in this. So for that case here IL into, so when switch is off means here this D 1 minus D into T divided by T. So switch off position. This is 1 minus D current time. Now here IL into 1 minus D 1 minus d that equals to I naught by 1 minus d into 1 minus d that equals to I naught only. IL equals to this is ID current. So this is for only average. Now what about the RMS value? RMS value equals to square root of 1 minus d into t by t, that is IL. So that equals to IL into square root of 1 minus d. So now here I naught by 1 minus d is the IL. So that is 1 minus d that equals to I naught by square root of 1 minus d is the I diode RMS value. So now this is the case for diode average value is I naught and diode RMS value is the I naught by 1 minus d under root. And ripple in the capacitor. Ripple in the capacitor means when switch is on. And what about this one here? Minus I naught, IC equals to minus I naught. So if you apply KCL when switch is on, if you apply KCL here, so now here IC plus I naught equals to 0. Inductor current is, there is no inductor current. IC equals to minus I naught. So now here IC, inductor current, capacitor current equals to, so C dV by dt that equals to minus I naught. So now here this is VC. So now here dVC by dt equals to minus I naught by C. And next here if you do the calculations here, del VC we need to calculate. So ripple in the capacitor voltage. So now if you integrate it, so now here integral of maximum, so V maximum to V minimum, so dV dt, and next that equals to integral of, so now here, so minus 0 to dt, so that is during on minus I naught by C. So now here, so this value equals to minus V plus V minimum to here V minimum minus V maximum is equal to minus I naught by C into dt only. So now here this is minus del Vc that equals to minus I naught C d into t, and now here del Vc equals to I naught into d by this t means 1 by Fc. So this is the formula. Del Vc equals to I naught into d by F into C. F into C. Now substitute this I naught equals to V naught by R, and V naught equals to d into Vs by 1 minus d. So d into Vs by 1 minus d. Now here this is into R. Substitute in this, you will get the answer. So d into Vs by R into 1 minus d into Fc. This is the formula. Just you substitute in this, you will get the final value. So this is ripple in the inductor. And next here at what? So now here del Vc is directly proportional to the d only. So when this one is increasing, so this is increasing for the maximum value of d only. Here del Vc is maximum. And next here critical inductance means here LC. So now here the minimum value of inductance, so for which the inductor current becomes just continuous. So now here inductor current just becomes continuous. For that case here, so what I will do here, IL minimum is equals to 0. Now IL minimum equals to IL minus del IL by 2 is equals to 0. IL means here IL equals to, what is the formula? I naught divided by 1 minus d. I naught equals to I naught divided by 1 minus d. So now here, so minus del IC means here, del IC means V into S into d by F into L is equals to 0. So now here I naught means here V naught by 1 minus d, and minus d into Vs into F into L is equals to 0. So now this is the case, and now V naught equals to V naught equals to, what is the formula? V naught equals to D into Vs divided by 1 minus D. Sorry. V naught, sorry. Here this is divided by R, and next here this is R, 1 minus D into whole square. Sorry, I will write it again here. So now V naught by 1 R into 1 minus D, R into 1 minus D is equal to D into Vs into F into L. So now here V naught means, so D into Vs divided by 1 minus D by R into 1 minus D is equal to D into Vs by Fl. So now dvs gets cancelled, and now here this is LC, inductance. So LC is here. So R into 1 minus D whole square, R into 1 minus D whole square, and here this is del IR. So this is denominator, there is a 2 and 2, and this is 2F. This is the critical inductance formula. So critical inductance formula equals to D into 1 minus D square by 2F. This is the case for critical inductance. And next, what about the critical capacitance? CC is equals to the minimum value of capacitance for which the capacitor voltage, output voltage, becomes just continuous. So now here what you will do, V naught is equals to V naught minus del Vc by 2 equals to 0. And now here V naught means, here V naught equals to del Vc formula is equals to minus I naught. So now here you write here is equals to V naught is equals to del Vc by 2. So now here plus I naught into D by F into C. So now here this is the formula. Now here what you will do here, so V naught by R you can write it F into C by V naught. So V naught gets cancelled. This is the C only. So critical capacitance. So C equals to critical capacitance D by 2 into F only, F into R only. This is 2. There is a 2. This is 2. 2 into Fr. So critical capacitance equals to 2 by F into R. So now coming to the conclusions. So now here VL on is equals to Vs only, and this one equals to minus I naught, and this one when switch is off, so Vs minus V naught only, and when switch is off, so the capacitor current equals to IL minus I naught. Now from the old second balance, so V naught equals to Vs by 1 minus D. So this is the formula, and from the ampere second balance, IL equals to I naught divided by 1 minus D. And ripple in the inductance, the del IL equals to, so now D into Vs divided by F into L. Now here IL maximum equals IL plus del IL by 2. So now here IL is this one and del IL, and next IL minimum equals IL minus del IL divided by 2. Source current equals to IS equals to V naught I naught divided by Vs. Switch current for average ISW average equals to I naught under D by 1 minus D only, and next ISW RMS equals to I naught by 1 minus D under root, and next here this one ID average is equals to I naught into root D by 1 minus D, and next ISW RMS value equals to I naught by 1 minus D under root. So now here ripple in the capacitor voltage del Vc is equals to, so D into I naught divided by F into C, and ripple in the maximum means that is directly proportional to the Vs only. So that equals to D into Vs divided by R into 1 minus D into Fc, directly proportional to the Vs means, so del Vc is directly proportional to the Vs. So depending on the supply voltage and duty cycle, and critical Inductance and critical capacitance equals to D into 1 minus D whole square divided by 2E into 2, 2F into R, this one. And next here CC is equals to CC, critical capacitance equals to D by 2F R, this one. So now here these are the formulas. When switch is on, then find the VL and VC. So now when switch is off, VL and VC, volt second balance, ampere second balance, ripple in the capacitor, IL minimum, maximum, source current, switch current, diode current, ripple in the capacitor. And next duty cycle, ripple is maximum, critical inductance and critical capacitance. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.